I welcome you to the live session of this particular course, that is robotics. I hope you are enjoying this particular course. I have received a few queries. I will try to give reply one after another. Now, the first query which I got is as follows. I can't able to get how to calculate mobility or degrees of freedom. Can you help me out, sir? Now, to answer this, actually what you will have to do is, I will have to take the help of the groupless criteria which I have already discussed. So, let me repeat. Now, for a spatial manipulator, the groupless criteria can be written as like the degrees of freedom or the mobility, that is nothing but 6 n minus summation I equals to 1 to m 6 minus C I. Now, here the n is nothing but the number of the moving links, and m is the number of joints, and C I is nothing but the connectivity of the ith joint. Now, this is for the spatial manipulator. Now, this is the spatial manipulator. Now, if I consider the planar manipulator, the mobility m, this will become your 3 n minus summation I equals to 1 to m 3 minus C I. Now, here once again C I indicates the connectivity of the ith joint, and n is nothing but the number of moving links. Now, here let me take a very simple example of a 4 bar mechanism. Supposing that if I consider a 4 bar mechanism something like this. Now, this is the fixed link, and this is the input link, this is the coupler, and this is nothing but the output link. Now, this is the planar mechanism. Now, if I consider what is the value of this particular n is nothing but the number of moving links. So, I have got 1, 2, 3. So, there are 3 moving links, and this is nothing but the fixed link. Then what is the value of small m? M will be 1, 2, 3, 4. So, I have got one revolute joint, another revolute joint, another revolute joint, another revolute joint, and this particular revolute joint is having one connectivity. So, 3 minus C I summation I equals to 1 to m. So, here there is one connectivity, that means it is going to offer 2 constraint, like 3 minus 1 is 2. So, 2 plus 2 4 plus 2 6 plus 2 8. So, I have got 8 such constraints here. Now, what should be the mobility or the degrees of freedom or this 4 bar mechanism? The degrees of freedom of this 4 bar mechanism m is nothing but 3 multiplied by, there are 3 moving links, not 4. So, 3 multiplied by 3 minus 8. So, this is nothing but 1. So, this 4 bar mechanism is having only 1 degree of freedom or 1 mobility level. Now, this is for the planar. Similarly, for the spatial manipulator, using this particular formula, so you can find out what is the mobility or degrees of freedom of a robotic system. So, I think I am clear to you. The next is, the next query is your how the precision is actually achieved in real application. Now, this precision if you want to achieve in robotic application, so we will have to take care of a few things. Now, this precision depends on the resolution of a robotic system, that is nothing but the least count of a robotic system. It also depends on the accuracy of the control system, that is your the closed loop control system which I am going to use, and moreover it depends on the nature of the joints. For example, if I consider the prismatic joint, the prismatic joint is having better precision compared to the rotary joints like the revolute joint. So, I hope this is clear, this particular query is clear to you. The next is your the third one, the third query. I got interested in robotics while doing this course. Suggest me, as I have completed my maybe mechanical, that what areas are there for further master education in India and abroad, and please state its domain of studies in foreign countries. Now, remember one thing, in robotics there are 4 distinct domains. For example, say the kinematics, dynamics, control scheme and intelligent issues. Now, these kinematics and dynamics are coming under the mechanical engineering, then comes the control scheme is coming under electrical engineering, and the intelligent issues are coming under the computer science. Now, if you are BTech in mechanical, so what you can do is you can concentrate on kinematics and dynamics first, and then try to get the detailed information of these fields, and then you can design and develop some robotic system depending on the need. But for this robotic system to work, definitely you will have to go for the control system, and you will have to make it intelligent and autonomous. So, truly speaking, all 4 modules of robotics you will have to learn, and after this most probably you are doing graduation. So, after the graduation you can join postgraduate, you can also join for your PhD either in India or abroad, and what you will have to do is, so you will have to concentrate on a particular module and go to the depth. But in this particular course, what I am going to do is, I am just going to give you the overall information of all 4 modules of robotics. The next query is, sir, give more examples. Now, here my further query is that you need more examples in which topic, because in each of the topics which I have discussed here in this course, so I have taken a large number of numerical examples and I have solved it. Now, if you need some more numerical examples, so my advice should be, please go through the textbook of this particular course and other reference books. So, in the exercise you will be getting a large number of numerical examples, but so far as you can remember, so in this particular course all the topics have been discussed with the help of some numerical examples. So, I think I am clear to your query. The next is, can you give the real examples? Now, here I have got one further query, please clear about the topic rolling, pitching and yawing. Sir, give more examples. Now, this rolling, pitching and yawing, this particular concept has come from the movement of a ship. Supposing that the ship is in say deep sea, now there you will find the ship is subjected to 3 types of basic motions. One is called the rolling, another is pitching, another is yawing. Now, by definition this rolling, pitching and yawing, so here the rotations are taken with respect to or about 3 independent axes. For example, if the rotation is taken with respect to or about x, we call it that this is a rolling motion. If the rotation is taken with respect to or about the pitch about the y axis, that is called the pitching movement, and if the rotation is taken about the z axis, then we call it this is the yawing movement. Now, let me take a very simple example. Now, supposing that, so this is the ship which is in deep sea. Okay. Now, here, so I am just going to define what do you mean by this rolling, pitching and yawing. The moment we consider this type of movement of the ship, so that is known as the rolling movement. Then comes, if I consider, so this type of movement, that is called the pitching movement, and then if I get this type of movement, that is called the yawing movement. Now, the moment I am considering this rolling movement, so this type of rotation, so this is the axis about which I am taking the rotation. So, this is nothing but x. The moment we consider, so this type of movement of the ship, that is called the pitching movement. So, this is called the pitching movement, as if this is the axis about which I am taking the rotation, and the moment we consider the yawing movement, say as if this is the axis about which I am taking the rotation. Now, this concept of rolling, pitching and yawing have been copied in robotics. So, just to represent the orientation of the end effector with respect to the base coordinate frame. So, I think I am clear about this, the basic concept of the rolling, pitching and yawing. Now, the mathematical expression how to tackle it, that I have already discussed and I have kept it in my PPT also. So, I will request you to see it once again. So, I hope the definitions of this rolling, pitching and yawing are clear to you. The next is the next query, can you give the real examples? Now, I have got one further query that we have given a large number of examples. For example, the examples of the robots, okay, the applications of the robots. For example, say the robots are used in manufacturing unit, as I mentioned, it is used in milling, the drilling, grinding, for doing some sort of pick and place type of operation, then some sort of assembly job. Robots are also used in medical science, for example, telesurgery, then comes the multi-legged capsule type of robot, and there are some other applications. Robots are extremely extensively used in space science, in agriculture. Okay. Now, here if you are talking about this real examples means this type of application. So, I think I am able to give you the reply, but if you want to mean about the numerical examples. Okay. So, once again you will have to see the textbook reference books which I have already mentioned. You will have to see their exercise problems, the numerical examples. So, I think I am done with this particular the query. The next is the future and advanced equipment in the robotics. Now, regarding the equipment in robotics, like if you want to develop a robot, it has got a few components which I have already mentioned, which I have already discussed in details. For example, it has got a fixed base, there are some links, there are some joints, at each of the joint we have got a motors, and if you want to make it intelligent, like we will have to take the help of some camera or sensors, and those are to be mounted. Now, here if you want to mean what should be the advanced equipment used in robots. So, I will have to mention that if you see this type of the motors are to be very sophisticated one, and generally we use some sort of servo control robots. Now, these sensors, the cameras which we are going to use, they should have very advanced specification. For example, the camera should be high speed camera, and it should be connected to its inbuilt hardware for image analysis. Then, if if we talk about the sensors, we should have very sophisticated, very accurate sensors, and we will have to collect this particular sensory data. Sometimes we take the help of some sort of multi-sensory data, like we collect data with the help of a number of sensors, and with the help of this data collected through different type of sensors. So, what we do is we try to extract some useful information using the principle of the multi-sensory data fusion. So, I think I am done with this particular the query. The next query is, respected sir, thank you very much for giving us your valuable time. I once again thank you. I wants to ask that is there any special software required for understanding the programming language of robot? The answer is, I should say it is partly yes. For example, you might have heard about the VAL programming, versatile assembly language programming, which I have already discussed in my lecture. Now, this particular VAL programming, if you see the versatile assembly language which is suitable for the Puma series robot. Now, some of the commands, some of the VAL commands are similar to the basic commands which I have already mentioned, and basic is nothing but the beginner's all purpose symbolic instruction code, and that is nothing but a programming language. So, some of the basic commands we have copied here in VAL. So, if you know these basic commands, the basic programming, so that is going to help you in this particular the VAL, but you need not know very sophisticated language like Python and some other like C++. So, those things are not required. If you have some preliminary information of the basic programming, so you will be able to understand. So, this particular the VAL programming which is suitable for the Puma series robot. Now, here I have got another online query, how to distinguish between a robot and CNC machine or high speed machine. Now, this I have already mentioned that CNC machines are not called the robots. Now, it depends on the level of reprogrammability. Now, let me take a very simple example. Supposing that say in my shop floor workshop, say I have got a CNC machine. Now, with the help of this CNC machine, I can perform a variety of machining tasks. For example, I can do turning, I can do thread cutting, I can do little bit of milling and all such things. Okay. Now, on the other hand, in the same shop floor or same workshop, if I have got a robot. So, with the help of same robot, we can solve a variety of tasks. For the same robot can be used to do some sort of drilling, I can do milling, grinding, pick and place type of operation. The same robot with little bit of change in the end effector and the programming can also be used for the welding. So, the level of reprogrammability of a robot is much more compared to that of a CNC machine, and that is why both are computer controlled machines, automatic machines, but the CNC machine is not a robot. The robot is something higher compared to the CNC machine in terms of the level of reprogrammability. So, I think I am clear to you. Now, there is another query: how different are consumer robots from industrial robots, and what are the main differences to be taken into consideration. Now, if we consider the industrial robot, now this industrial robot has to be at least 6 degrees of freedom robot, because we will have to manipulate some 3D object in 3D space, for which 6 degrees of freedom is required. Now, these particular industrial robots are to be more robust, because we will have to handle the real production, and these robots, industrial robots, are generally used to increase the productivity, to improve the quality. So, it has to be robust enough. On the other hand, the consumer robots should be robust, but it may not be so much robust like industrial robots, because there the type of application is not so much rough and tough. So, the consumer robots could be slightly more sophisticated, and it could be less robust also compared to the industrial robots. So, I think I am clear, just to give answer to this particular the doubt. The next doubt is the next query: will the programming language be taught? Now, this I have already taught. I have already taught the BAL programming, okay, like to how to give instruction or how to teach a Puma series robot with the help of this BAL programming. So, that I have already taught, and in fact, I have showed some real experiment also on the real manipulator, the serial manipulator, like the 6 degrees of freedom serial manipulator. So, I hope you got that particular PPTs, and you have already listened to that particular the lecture given by me. The next query is: sir, I need to understand the instantaneous position calculation for a biped to avoid collision, and how to put it in 5th order polynomial using the MATLAB. Now, if you want to avoid, if your biped robot is going to avoid the collision while walking, so this particular robot should be intelligent and autonomous enough. The robot should be able to collect information of the environment online, and it should be able to take the decision as the situation demands. But as you have mentioned that you are going to use a 5th order polynomial using that particular the MATLAB programming. Now, if you want to use 5th order polynomial, so this 5th order polynomial will have the 6 unknowns, and those 6 unknowns you will have to solve, and for solving the 6 unknowns you will have to know at least 6 known conditions. Now, if you have 6 known conditions, then you can very easily determine the coefficient of the 5th order polynomial, and you can control the movement accordingly. So, I think I am clear. Now, the next query is: I am CS student, one thing remains always in my mind, that robotics belongs to mechanical branch. Is that true? Answer is no, because robotics has got the 4 modules, the distinct modules, but this is an interdisciplinary subject. Now, if you want to be a true roboticist, the real expert of robotics, so you will have to know the fundamentals of all 4 modules. Now, for example, say as you are a CS student, you can concentrate more on your the intelligent issues, like how to make the robot more intelligent and autonomous, and moreover actually you can also concentrate on the sensors and computer vision or the robot vision. So, the next is, if not, what is the role of CS student in robotics? So, that I have already mentioned. Now, here I have got one online query. As being computer science background, I have interest in robotics, but allergy is the electronics in it. So, should I go ahead and pursue its course? Now, as I told that if you want to become a true roboticist, you will have to understand the fundamentals of all the basic subjects. So, you cannot avoid this particular the basics of electronics, because ultimately you will have to implement in the hardware and you will have to control it. Now, supposing that you have designed a robot, you have fabricated the robot, and supposing that being a computer scientist, so you have made the robot intelligent, but if you do not know how to implement on the hardware, so very purpose of learning all such things will be lost. So, my suggestion is the basic, the fundamentals of all 4 modules. So, gradually you will have to start learning, but as a computer science, so you can go to the depth of intelligent issues and computer vision. So, I think I am clear. The next online query, if I use move instead of move S, will the manipulator follow the straight path? There is no guarantee. Now, the way it follows is actually the moment we are going to give some sort of task. I have already discussed the trajectory planning, that the course on trajectory planning I have already delivered that particular lecture. I think that was there in your the 4th week lecture, I hope. Okay. Now, the moment the robot gets that type of instruction that it will have to move. So, what it does is it will try to find out the variation of the joint angles and it will try to fit some trajectory. So, trajectory planning has to be done, and the way the robot takes the movement, it will try to take the optimal or the near optimal path in terms of power consumption or the energy consumption. Now, if you use move in place of move S, there is a possibility that it can still follow the straight path. It depends on whether that is the optimal in terms of power consumption. But if you give the command move S, it is bound to follow that particular the straight path. So, I think I am clear. The next you have written, straight line is the shortest path between the 2 points. So, by default will it follow? So, I think I have already answered. EPS, what is the importance of move S? Now, the importance of move S, as I told, if you give move, there is no guarantee that it is going to follow always that straight path, because there could be some obstacle in between, or there could be some restriction, that supposing the starting from point 1, say I will have to reach point 10, but there could be some constraint like I will have to go to 2, 3, 4, 5, 6 something like all such intermediate points before I reach that particular the 10. So, directly I cannot follow the straight path starting from 1 to the point 10. So, these both are important, both move and move S are important, and once again let me repeat. So, if you give move in place of move S, there is no guarantee that it is going to follow the straight path. So, I think I am clear. Now, the next query which I have got here is as follows, like nano robotic lab, whether it is available in India. Now, so far as I can remember, there is no such very sophisticated nano robotics lab in India as on today. Now, the next query is industry related to robotics. Now, nowadays many manufacturing units, like sophisticated manufacturing units, they are going to use the robots. Okay. They are using for different manufacturing processes. for example, as I have already mentioned, like drilling, milling, grinding, pick and place, assembly. So, this type of job. Now, nowadays actually there are a few the robotics manufacturing company also. For example, if you see in India, there are a few robot manufacturing industry, particularly in Delhi region, then in Pune, then Bangalore, we have got a few robotics manufacturing company. Now, the next query is how effectively robotics can be used in the field of mechanical engineering. Now, this I have already answered, like mechanical engineering deals with the kinematics and dynamics, although we also study the control scheme and intelligent issues. Now, being a mechanical engineer, actually we can use robots in manufacturing unit to perform a variety of manufacturing tasks. So, I think I am clear. So, one online query I have got, sir, please suggest some simulation software that must be learned for robotics. Now, I have got a suggestion here. So, there are a few simulation software related to kinematics and dynamics. Now, these are all downloadable. For example, say in Google search, if you just give a search that a robot simulation package for kinematics or robot kinematics simulation package. So, I hope you will be getting a few ready-made simulation package. Similarly, for the dynamics also there are some simulation package. Moreover, you must be aware that nowadays Adams is having another very popular software package, and they are having the inbuilt kinematics and dynamics module. So, the next query is your the next is not well teach. I am very much thankful to you for this particular comments. Now, here I just want to add that my experience in robotics, I am now 23 years running. So, I started learning robotics bit late during my PhD in the year 1995 at IIT Kanpur, India. Now, so I did not get the opportunity to study robotics during my during my MTech or during my undergraduate, but I got the opportunity during my PhD, the doctoral study only. So, I am trying my level best to learn as much as possible, and I have already written a textbook, guided a large number of PhD students, and a large number of PhD students are working now under my guidance. And I have learnt this particular subject on robotics as a student, as a teacher, as a researcher, as a writer of a textbook, and as a lecturer or a professor for this particular the MOOC course. So, but still there is no end of learning, I am still learning. I hope and I wish that you will become a much better roboticist compared to me. I wish you all the best. Now, the next query is your, can you develop a robot identical to a human body? Let me answer this, then I will come this. Now, can you develop a robot identical to a human body? Now, just to answer this, our human body is very much complicated, and it is very difficult to exactly copy everything and develop in the artificial way. Now, in robotics, I have already mentioned that we try to copy and model artificially the hand of a human being, the head of a human being, the heart of a human being, and till today, so far as I know, the most sophisticated robot is known as her name is Sophia. Sophia, according to me, is the most sophisticated robot, and Sophia is intelligent and emotional too. Okay. But there are a few pending research issues to reach the level of this particular the human being. So, I think I am clear. The next is your dear sir, how to find a force, torque, a serial manipulator using Newton Euler formulation. Okay, before I go for this, let me clear this particular the online query first, then I will come back to this. Now, difference between manipulator and actuator. Now, this manipulator is what? Manipulator is nothing but a mechanical hand. That means, so this particular hand we just want to copy this human hand, we want to copy in the artificial way in the form of a manipulator. Now, this actuator by actuator means which helps in actuation. That means, your actuator could be nothing but a motor sort of thing. So, we called actuator is nothing but a motor, but in manipulator at each of the joints we have got the motors and there are a few links and two links are joined by a joint, and at the joint we put an actuator, that is nothing but is the motor. So, this is the difference between the manipulator and actuator. Now, here how to find a force torque of a serial manipulator using Newton Euler formulation. Now, I think this robot dynamics I am going to discuss in the 5th week. Now, the 5th week is running now. So, in my lecture you will understand that I have used a particular technique that is called the Lagrange Euler formulation. There are some other formulation also, for example, Newton Euler is another very popular formulation for this particular the dynamics or how to find out the joint torque or the joint force. Now, let me tell you something regarding this Newton Euler formulation, and I will tell you the reason behind going for this Lagrange Euler in place of the Newton Euler. So, in this particular the MOOC course. Now, this course is actually a 8 weeks course, 20 hours lecture, okay. And what I have decided? I decided to cover all 4 modules of robots or the robotics like kinematics, dynamics, control scheme and your intelligent issues. So, this is not a course only on dynamics or only on kinematics. Okay. Now, if I just go for an advanced course on robot dynamics, so there I can discuss all the approaches available, but as I told I am just going to tell you the reason behind going for the Lagrange Euler, but not for this particular the Newton Euler formulation. Now, before I answer this, so let me tell you this particular the Newton Euler formulation first. Now, Newton Euler formulation is also very simple and we follow some recursive formula. For example, say if you see this Euler approach, the Euler approach if you see, now this torque is nothing but I omega dot plus omega cross I omega. So, that type of thing. So, I omega dot then omega cross I omega. So, that type of thing. Now, here actually we try to find out. So, this particular the joint torque and this Newton law force is nothing but mass into acceleration, and we take the help of some sort of recursive formula. So, what we do is initially the velocity, that is the linear velocity or the angular velocity, the linear velocity that is v we take that is equals to 0, the angular velocity we take equals to 0, then comes the acceleration, the linear acceleration that we consider, that is your say A is nothing but the acceleration due to gravity, that is g, and your angular acceleration that is your omega dot, we just take it equals to 0. So, what we do is iteratively we try to update this particular the linear velocity, linear acceleration, angular velocity, angular acceleration, and then through some iterative method ultimately we try to derive this particular the joint torque, and if it is a linear joint, the joint force. Now, the basic difference between this Newton Euler and the Lagrange Euler approach which I have used in this particular course is, if you follow the Lagrange Euler, so you will be getting the torque expression in a very structured way, and here also you will be getting the same expression if you follow this Newton Euler. But as I told, So, there are some other methods also, like how to tackle this robot dynamics, but as I told that this is not the advanced course on your the only dynamics or kinematics and dynamics. So, I did not discuss very purposefully all the approaches available. Now, the next query is what is recursive Newton-Euler equation of motion. So, this I have already discussed little bit. What is the generalized D'Alembert's equation? I think it will be D'Alembert's equations of motion in robot dynamics. Now, in D'Alembert's principle, actually what we do is we consider the virtual work. Now, this virtual work, if you see this particular the expression of the virtual work. So, this delta W, if it is the virtual work, so this is nothing but integration, then comes your delta R T. I am just going to explain the different terms. This is multiplied by your dr dot or delta R dot, then comes your mass minus F external force. Okay. So, this external force, and so this is what? This is nothing but the displacement. R represent the displacement, R double dot is nothing but the acceleration. This is the elemental mass and this is the external force which is acting on that particular the small element, and this we put it equals to 0. So, this is actually the D'Alembert's principle which is generally used to derive the joint torques and forces. Now, as I told, due to the same reason, so in this particular course I did not discuss all such methods in much more details. Instead, I concentrate only on the Lagrange Euler the formulation. So, I think I have got some online queries. In case of magnetic gripper, when you use electromagnet, in the time of releasing, why should you reverse the polarity? Is residual magnetism enough for lifting a heavy thing? Now, what you do is for this particular electromagnet, if you just reverse the polarity, so there is a possibility that the strength of the magnetic field between the gripper and this particular object will be weaker, and due to the self weight the magnetic object will be separated out. Now, there will be residual magnetism, but this residual magnetism may not be enough to grip that particular the objective that particular object, because the object is having its own self weight, and due to the self weight, although there will be some residual magnetism, but due to the self weight, so this particular magnetic object will be separated out from this magnetic gripper. Any other? Now, there is another online, can we develop the 6 axis industrial robot? The answer is yes. Okay. So, you can develop, there is no problem, only thing depending on the payload capacity, you will have to start with the payload capacity, you will have to check the strength of each of the links, the strength of the joints, you will have to carry out the kinematic analysis, you will have to carry out the dynamic analysis, and the specification of the robot or the capacity of the robots you will have to determine, because at each of the robotic joint there will be DC motor. So, you will have to find out the capacity of the motors, and once you have got all such things, you are ready to do the assembly, and you can also develop some control scheme, okay, just to control it in a very smooth way. So, this is possible, we can develop the industrial robots. Next is machine learning a part of robotics? Now, as I told that in robotics there are 4 modules. The 4th module, that is your intelligence, like the robot intelligence. So, this machine learning actually helps a lot in robot intelligence. Actually, in this particular course I have not discussed, I also teach soft computing, and that is nothing but the computational intelligence, that is artificial intelligence using the principle of soft computing, and using the soft computing principle we can make that particular the robot. So, those things has not been discussed in this robotics course, and for that we have got separate courses. Now, can you also explain it in brief? Are AI trained by machine learning only? Now, this artificial intelligence, the purpose of artificial intelligence is to copy the human brain in the artificial way. Now, if you see the literature, there are some traditional methods of AI and there are a few non-traditional methods like using the principle of the soft computing. For example, you can use fuzzy logic based motion planner, neural network based motion planner, fuzzy logic based adaptive controller, neural network based adaptive controller to make the robot intelligent and autonomous. The next query is your, so I think these things are all over. The next is there any future for mechanical engineers as robots will take place instead of human? This I have already discussed. Now, here one thing I just want to make it clear that if you use robots, robots are what? Those are automatic machine, multifunctional automatic machine. So, there are a few tasks which could be difficult for the human operator, particularly if the task is repetitive in nature and if you need more productivity and if you want to get better quality. Now, there actually we can replace the human operator by the robots, but please do not consider one thing that we are going to replace totally all the human beings by the robot. Now, in a sophisticated manufacturing unit, the robots will be working along with the human beings and due to this combined efforts. So, there is a possibility that we will be getting the products in better quality, the productivity will be the higher and at the same time the repetitive job will be able to handle more efficiently. So, I think I am clear. Now, the next query is how much occupying robots on a home environment, sir? Now, this question is not very much clear. I think you are going to ask like what is the applicability of robots in your in our home. Now, at our home we can use home environment. I think you are going to mention only that the home atmosphere, how to use the robot, but if you have some other things online you can further ask. The way I have understood your question is as follows, like in household application, like what are the areas where we can use the robots? We can use robots just to replace the maid servants, okay. And there are some household activities like for example, sweeping, cleaning utensils, giving medicines, okay, to some old people or that type of task actually we can assign to the robots. The next is which language should we study for robotics programming, C++ or Python? This I have already mentioned that if you want to learn the programming language for the robots, you need not learn a very sophisticated language like Python and others. So, what you need is a very basic commands like which I have already mentioned, and with the help of these basic commands, so very easily you can write down the robot programming. Now, I have already solved at least one examples in the lecture and we have shown these real experiments also, like how to teach a robot with the help of some programming language. Now, here actually I am getting one online query. Can you use continuous path robot as a point to point robot? Answer is yes, because continuous path robot is a more sophisticated one. Okay. For example, say if I have got a Puma like programmable universal machine for assembly, that is a continuous path robot used for spray painting, used for arc welding and used for milling. So, different types of continuous path tasks. Now, the same robot, the same Puma, I can also use it for point to point robot, there is no problem. For example, say I can solve some sort of pick and place type of operation. I can solve, I can do some sort of spot welding before I go for the continuous arc welding, or I can just make some drilled hole on steel plate at some pre-specified location and so on. The next online query, can we use normal DC motor in robots? You can use normal DC motor provided it is servo controlled, because at each of the robotic joint we want to get a very accurate movement, and if you want to ensure that accurate movement, so what you will have to do is there must be closed loop control system, and these particular robot motors are to be servo controlled motors. The next is, sir, I am doing my mini project on gesture controlled prosthetic human hand in robotics. I am using slider crank mechanism to achieve the movement of joints of the fingers. So, I would like to know what will a servo motor be suitable to bear a load of 100 grams? Answer is yes. So, this particular servo motor will be able to handle, so this type of small load like 100 grams. Okay. And once again, actually I encourage you, because you have started working on this particular the robotics on this problem. So, I hope you will make a good success in this particular the problem. The next is your next query, sir, I want to pursue robotics in future. It is very good. So, I am deeply interested in this subject right from the school level only. What should be my right move after completion of this particular course? Now, this I have already mentioned that the purpose of this particular course is to discuss the fundamentals of 4 modules of robotics. Once again, let me repeat: kinematics, dynamics, control scheme and intelligent issues. And after attending this particular course, the module which you find to be more interesting, you concentrate, go to the depth and you try to learn more. But as I told that the basic or the fundamental information of all these 4 the modules you should know first before you concentrate on this particular the module, on a particular module in more depth. So, next is robot kinematics. So, I am sorry I could not understand the meaning of this particular question. Are you talking about the robot kinematics, the principle of robot kinematics? If it is so, that I have already discussed in much more details. So, please go through the lecture once again. So, I hope you will be able to get the clear idea of this particular field on robot kinematics. The next is, where can I get more numerical example on the concept discussed in the course? Now, let me repeat. Now, in this course, I have discussed a large number of numerical examples, but if you want to get more number of numerical examples, you will have to see the exercise of your textbook and the reference books, and on the exercise you will be getting a large number of numerical examples. But if you want to become a master of this particular the field of robotics, so you will have to solve a lot of numerical examples just to gain that particular the confidence. The next query is it possible for the robots to oversmart humans artificial intelligence? Now, this I have already mentioned, the robots are never going to fight with the human beings. Okay. In fact, we are designing and developing the robots just to serve our specific purposes. So, the robots always will be our control, within our control. We human beings will be able to control that particular robots. Robots are never going to control the human beings. The reverse is not true. So, you need not worry, and the robots we are going to use along with the human operators in modern industry just to ensure the better accuracy, the better productivity and the better quality. So, that is the purpose of designing and developing the robots. Okay. The next is, can we control robots in future as we can do today? Yes. So, is it possible that in future these advanced robots will become the biggest reason for World War III? Answer is no. Do not misunderstand, because we are developing robots, robots are not developing the human beings. So, we have got the control. So, you need not worry at all. The next is, sir, I have two questions. The first one, why do not you use some animation and videos to elaborate a topic? Now, this is a very good suggestion, but as I told, so in 8 weeks I am going to cover all 4 modules. Okay. That means, on an average, although that is not very meticulously followed, on an average each module is having only 2 weeks. Okay. Now, it is a bit difficult to go to much depth, so that I can cover each and everything. For example, say if I concentrate only on a course on kinematics or a course on dynamics, I can take the help of all the animation and videos just to show the robot kinematics, to explain the robot dynamics. But the purpose of this particular course is to give you the fundamental information of all the 4 modules of robotics, and so far as I can remember, the chapter on kinematics and dynamics I have discussed in much more details with suitable numerical example. Now, in future if we develop or some other professors develop some the specialized course on only robot kinematics or robot dynamics, or for example, if I develop some advanced course on robot kinematics and robot dynamics, I am definitely going to use all such animations and videos available. So, these are all actually available, these softwares are available nowadays, it is not a big problem. But remember one thing, before you go for using this animation and videos, the first thing you will have to ask whether you have understood the physics of robotics, whether you have understood the mathematics of robotics, that is much more important compared to using only this animation and videos while teaching this particular the kinematics and dynamics. So, this is actually my personal view, and that is why I did not consider any animation or videos. I wanted to concentrate on the fundamentals on physics and mathematics of robotics. Now, next is, can you give some more institute name where I can implement my robotics knowledge into practical work? You are very much welcome to IIT Kharagpur. We have started one new center for robotics under my headship. Okay. So, if you are willing to work in future on robotics, or if you want to do some internship, be in touch with me. I am student of mechanics 3rd year BTech degree. So, you are very much welcome if you want to do some sort of your internship, or if you want to carry out some sort of research. A large number of students are working now in the field of robotics at our place. Now, here there is one online query, in case of adhesive gripper, how to release the object. Now, in case of adhesive gripper is generally used for actually your very lightweight object. Now, for this lightweight object, for example, let me take the example of the frog. The frog, the way it preys, it collects its prey, that is the insect. So, the tongue is actually having some sort of adhesive. So, the frog throws its tongue just to collect that particular insect, and it puts it within the mouth and just swallow and digest. So, this is the way actually the frog, the way one frog collects its prey. The same thing you can also consider in robotics. Okay. In robotics, generally this adhesive gripper is used only for very lightweight objects, and this light, for example, if I just take one light object with the help of adhesive gripper. Now, if I just want to place it somewhere, now it will be little bit difficult to release the load, but we can do it So, because it is having less load, less weight, so releasing will be little bit difficult. So, you are correct, but generally we do not use any such adhesive gripper in industrial robots. Adhesive grippers are generally not used in industrial robots. Okay. So, you can say this is simply a concept, but it is not very extensively used in industrial applications. The next is your, sir, I want to know about robotics, give me basic information about robot. The whole course, that is the thing which I have done. So, please follow my lectures and try to concentrate, you will be getting lot of information. Robotics areas, research areas in robotics like kinematics and dynamics are well searched. There is less scope of doing some sort of research work, particularly kinematics is well searched. Dynamics there is little bit scope, okay. But the intelligent issues, the control scheme, the robot vision. So, those are the areas on which you can concentrate for the future research. Sir, I want to ask you, what is the latest robot in world? In my opinion, actually this is Sophia. Sophia is, in my opinion, is the latest. Okay. Then what do you mean by robotics and robot? This I have already discussed. Even if you see my first lecture, by robot we mean this is an automatic machine and it can be used to serve a variety of purposes, and robotics is the science which deals with the design, development and usage of the robots. So, next is I am an EE student. If I want to take my career in robotics and automation in this subject is sufficient for me, I have to do a particular course. Now, this particular course, the MOOC course which I am teaching now, this will give you the overall ideas and fundamentals of robotics, but being an electrical engineering student, if you want to go to the depth, so you will have to concentrate more on control scheme, the robot sensors, okay, and you will have to see how to develop this adaptive controller and all such things, and you can also think of some sort of hardware implementation. And robotics can replace human being in future, which can cause unemployment among the. So, this I have already discussed, so we should not be worried. Should we allow robots to enter in the human life? This I have already discussed. I want to ask about all parts of robotics. This I have already discussed. Next is the exam paper, will it be said by you? Answer is yes. Next, I am very passionate about robotics and I want to become a master of this field. What will be the next step then? First, you attend this particular course very meticulously, solve all the assignments and appear that particular test. Okay. You will learn a lot and you will be getting the initial momentum in robotics, so that you can start learning the other advanced areas in robotics. Sir, I want to be known about what is kinematics, potential energy, kinematic energy. This I have already mentioned. By kinematics, actually we mean we consider the relative movement of the different joints, different legs, but here we do not consider the reason behind that particular motion, that is the force or the torque. Then comes potential energy, all of you know, that is nothing but the mgh is the potential energy. Kinetic energy, this is not the kinematic energy, this is the kinetic energy, and by kinetic energy what I mean is half m v square. M is the mass and v is the velocity. If it is a linear velocity, half m v square. If it is a linear velocity, so half m v square, and if it is your rotary movement, that is half I omega square. Now, sir, I want to so this I have already done. The next is, can you please differentiate between accuracy and repeatability, as I found both are the same, and can you give more details and examples on resolution, accuracy and repeatability? This I have already mentioned. So, by resolution we means the least count of a particular robot. Okay. That means the level up to which we can go in terms of the precision. that is almost similar to the least count of a measuring device. Now, the concept of this accuracy and repeatability, supposing that say I have got, so let me, this example I have already taken, but let me take quickly once again this particular example. So, in Cartesian coordinate system x and y, supposing that I have got a robot say 2 degrees of freedom serial manipulator, if it is L1, if it is L2, the length of the link, this angle is theta 1, this angle is theta 2. So, very easily I can find out what is this x and y. Okay. So, x is nothing but L 1 cos theta 1 plus L 2 cos of theta 1 plus theta 2, this we have already studied, and y is nothing but L 1 sin theta 1 plus L 2 sin of theta 1 plus theta 2. Now, supposing that, so all the values of L 1, L 2, theta 1, theta 2 are given, can you not find out the position, that is the coordinate x and y? The answer is yes. Now, supposing that I have calculated, now I have got a 2 degrees of freedom serial manipulator and I am just going to control. So, I know L 1 and L 2, and with the help of 2 motors mounted at the 2 joints. So, I am just going to generate theta 1 and theta 2 as accurate as possible. Now, even if we are using the servo controlled motor, there is no guarantee that it is going to reach exactly this particular point. There is a possibility that the robot may reach this particular point at that reach this particular point. So, this particular difference is nothing but the accuracy of a robot. Now, supposing that using some teaching methods, I have already taught a robot that you reach this particular point. Now, once it has been taught, for example, say I have written the valve programming for a Puma series robot. Now, if I want to run that particular the command say 20 times. So, the first time I will be getting some position of the end effector, second time I will be getting another position, third time another position, and absolutely there is no guarantee that every time you will be getting exactly the same reached point, reached position. There could be some deviation. That deviation is nothing but the repeatability. So, I hope you have understood the difference between the accuracy, repeatability and resolution. They are basically not the same. So, there is a difference. Now, the next is future of last mile delivery drone robot. All of you are very much aware of this particular the air robot, that is your the drone. But even in this particular drone, there are some research issues, pending research issues. So, drone could be little bit intelligent, but let me take a very simple example, you will understand there are a few open ended problem. Supposing that I am just using one drone, the drone is in sky, and supposing that, so this particular drone is driven by say 6 motors and it is maintaining a particular height from the ground, and it is maintaining its stability. Now, supposing that due to some reason, so out of 6 motor, so 1 motor or 2 motors have become out of order, then what will happen to the stability of this particular drone? Will it be able to maintain the same height from the ground, and will it be able to maintain and that particular the stability? Then if yes, then how to do it? That is a very open ended research problem. So, there are many other research issues. A little more about resolution, repeatability I have already mentioned, and related to robotics. I think those things are related to robotics. So, those things I have already mentioned. Now, the lecture number 20 of week 4, another example of STR. I have already taken one STR, that is your sliding joint, that is a linear joint, translating joint and the revolute joint, that type of manipulator, and I think I have discussed how to assign the coordinate system, okay, and how to carry out this particular your kinematic analysis. Okay. Now, here I think you please make me clear. So, whatever you have written it here, I have read it. So, what you will have to do is, so supposing that I have got one STR, let me draw a very rough sketch of STR, and I will very briefly I will tell you what are the things to be done. Let me consider another STR slightly different from what I have already taken. So, let me consider that so let me consider one sphere something like this. So, this is your, I am just going to draw say one prismatic joint, that is a linear joint, somewhat a linear joint. So, here it is a very rough sketch. So, this is the fixed base. Now, this particular linear joint is going to slide something like this. Okay. And then I have got one twisting joint say. So, here I have got a twisting joint. Now, this particular twisting joint, it can rotate something like this. So, this is nothing but a twisting joint, this is a prismatic joint, and supposing that here I have got one revolute joint sort of thing. So, this is the revolute joint. Okay. So, this is nothing but a PTR robot. Okay. So, prismatic joint, then I have got a twisting joint here and I have got a revolute joint here. So, what you will have to do is at each end, of course, I have got a base coordinate system. So, this is one coordinate system. So, might be this is your x and this is your z, and z cross x is nothing but y. So, this is nothing but y. So, this is your the base coordinate system say B. Okay. Now, with respect to this, actually what you will have to do is, so you will have to assign the coordinate system. Now, this joint is what? This is a prismatic joint. So, the z axis will be along this particular direction. So, let me consider, so this is my z naught, this is my say x naught, and z cross x. So, y naught will be something like this. So, this is nothing but y naught. Now, comes here, so this particular joint, so this is nothing but a twisting joint. So, z is along this particular direction. So, this is nothing but z 1, and let me assume that this is my x 1 and z cross x is nothing but, so this is nothing but y 1. Now, this is a revolute joint. So, what you do is z is say this particular direction. So, I am consider opposite to this is the z. Okay. So, this is nothing but your z 2, and let me consider this is your x 2 and z cross x. So, this will be nothing but my y 2, and the same coordinate system you copy it here. So, this is nothing but z 3, this is nothing but x 3, and this is your y 3. Now, you can just prepare the DH parameter table and you can carry out the forward kinematics calculation. So, I hope you got it. Is there any online query? So, I hope I am able to clear your doubts, and once again if there are further doubts, we are going to meet on 24th September. I hope I am clear. Okay. And all of you please follow all the lectures, and not only once, try to read and try to practice at least 2-3 times. The numerical examples also you go on practicing, assignment you solve, and I hope all of you will be able to do very good in exam also. I wish you all the best. Thank you.